Welcome to the presentation for this lab. This lab is about arithmetic logic unit. As you can see, I've drawn this schematic using the previous lab video, the part 1 lab video. And once you're done with these schematic symbols, then you can go ahead and try to understand the timing diagram from the simulator behavioral model. Let's go ahead and see the output. Okay, so we're gonna have the timing diagram right now. So as you can see, this is the timing diagram of the arithmetic logical unit, and I have, for example, I have checked with 00 or 01. So in order to, if you want to check like something like the AND or you want to check the adder beat, then you can drag this one in here and check with any kind of output. For example, I'm using A as 0 and B as 1, and all the other inputs are 0. So for example, I'm gonna choose 1 0 to see the behavior of the adder beat line. So let's go ahead and change it. So it'd be 1 0, right? Because 1 0 is my output for the adder beat, right? Okay, so let's go ahead and apply that one. Okay, and then I can put this one. Now, as you can see, for the adder beat, I have used like 0, 1. The result is 1, and the carry out is 0 because there is only a single bit in here. So using these criteria, you can change the operation and check the result for each of the operations you have, like AND gate, OR gate, and the adder beat. And the way the operation is for the multiplexer. Using the multiplexer, you can choose which kind of output you want to see in your timing diagram. So that's it for the timing diagram. Let's go ahead and check the VHDL code and see the behavioral model. Now I have generated the VHDL test bench using the previous methods that I've showed you in the previous labs. And I know you can do that, so I'll not go over to that again. So here you just need to put the arguments for the input signals, and then you just need to put the function, like the operation for test bench process. So let's get started with the argument in the A, B, and A invert, B invert, carry in, and the less ports. So in here, I just put the same thing as before, like you just put the string data type for your A, B, A invert, B invert, carry in, and for the less input ports. So once you're done with that, you're going to have the operation, which is similar, like it's the same thing as before. You just need to put the bits as you have done in your previous lab, in lab 3. So in lab 3, you put four bits, but in here for the operation, as you know, the multiplexers, if you wanna change the mode of operation, you need to have the operation bits. So in our case, we have 4 types of types of operation. That's why you chose 2 bits for the operation, and that's why you have 1 down to 0, and we initialize them as 0, 0. So once you're done with the operation, then go ahead, don't change anything with the port map. Then start with the process. The process has several operations. First, you can check. I mean, it's an arbitrary choice. You can have whatever you want, but you can follow my procedure as well. Like first of all, I checked with A or B. For that, I put A as 0, B as 1. I didn't change A invert, like it would be the A invert will be 0 and B invert will be 0, and carry in should it's 0 as well, and less as 0. And then your operation it's in the mode of 0, 1. That means it's going to perform the OR operation and then wait for 100 nanoseconds. After doing that, you can go ahead and change the operation again. So in here, I just change it as the AND mode, but there you can observe the tilde in here. You can say tilde or tilde. So tilde symbol in here, that means it should be the not, like invert. So it'll be inverted. So then you can check the output inputs for A and B, like A as 1, B as 0, and then A invert will be 0. But for B invert, it should be 1 because you have put a tilde in here. So that's why it's going to get inverted. And then you have the carry in as 0, less as 0. And the operation, as you are dealing with, as we will deal with AND operation, then you can put it as 0, 0, because we know 0, 0. I mean, we have assigned AND operation as 0, 0. So you can do that as well. Then after that, you wait for 100 nanoseconds, then go ahead and another one, go ahead and change the function for the Boolean operation. In here, you can check it with A plus B. That means it's going to get what? It's going to have your output as the addition, we know. So add A and B and then check the output. So in here, I used 1 as A as 1, then B as 1 as well. And A invert will be 0 because there is no tilde. So, and B invert will be 0 as well. Carry in will be 0, less 0, and your operation, as it is the adder circuit, so it would be 1, 0. And then wait for another 100 nanoseconds. So notice that there's something there are some differences between those single digit and more than 1 digit. So you have, if you have single digit, then if you need to put single code. But when you have more than 1 bit, that means you have to use double codes. So as you can see in here, whenever I assign the operation, I use double codes. So once you're done with this one, okay, so another one is left. It's about the subtraction. So you can put the subtraction function in here, like A negative B. So A, you can assign A as 1, B as 0, and then A invert as 0 in here, and then B invert, as you know. So you're using the adder circuit as a subtraction operation. So in that case, you need to use the B invert, right? So you put the B invert as 1, and also you can put the carry in as 1, and check the output for the operation for adder circuit. Like that means you're gonna assign 1, 0 for the operation. So then wait for 100 nanoseconds again. In this way, you can assign the output, assign the input ports, and then check the timing diagram using the previous, checking the syntax. We have talked about these processes in our previous lab. So you can check the behavioral syntax, check syntax, and then check the behavioral model, then go ahead and try to understand the timing diagram. Let's go ahead and check the timing diagram there. So as you can see, this is the timing diagram. Once you run the simulation, then you'll get this kind of output. First, it'll be like random. Then you need to click on zoom to full view. Then you'll get this kind of timing diagram, or you can say clock signals. Like signals. So as you can see, for 00, it should be the AND operation, and you can check the output by dragging the cursor there. As you can see, this is the this is 0, 1, and this is 1, 0, and you can check the result there. So in here, the 1, 1, it's the adder function, like adder circuit. So in that case, you will have the result as 0, and carry out will be 1, as you can see. What about the inversion? Like, let's see. So this one has B inversion. That means what? And it has an operation of AND gate. So you have A as 1, B as 0, but since you're using B invert as 1, then it would be 1 times 1, right? Then your result will be 1. So in that way, you can check the output using your VHDL code and see what's going on. So in your report, you should have this kind of waveform, this kind of timing diagram. So that's it, guys. Thanks for watching. We'll meet again for the next lab.